Bismillah Rahman Rahim. Students, hope you all are fine. As you know that we are discussing chapter number 10, properties of light. So, today the topic of our discussion is convex and concave mirrors. The mirrors we use at homes are plane mirrors. They have flat surfaces. So the plane mirrors will form your identical or twin image on the mirror. We have already studied plane mirrors in detail. There are different types of mirrors. These are mirrors with curved surfaces and they are of two types, namely convex mirrors and concave mirrors. In this topic, we shall discuss curved mirrors and their applications or uses. So firstly, we will discuss convex mirrors. Now, what is convex mirror? A convex mirror has its surface curved in such a way that its outer surface reflects light. These reflective surfaces basically differentiate between convex and concave mirrors. Students, you should remember that the mirror whose outer surface reflects light is known as convex mirror. For example, the bottom of the spherical silver bowl or the surface of a finely polished spoon act as a convex mirror as shown in the figure below. Now, how a convex mirror behaves with an incident light. A convex mirror always separates the light, it will not focus the light. So, a convex mirror separates the light after reflection. The mirror surface is curved with the outer surface made reflecting. The reflecting surface is drawn smooth and the rough surface is made haired. A horizontal line passes through the mirror center. This horizontal line is known as principal axis. In other words, we can say that the straight horizontal line which divides the mirrors into two equal parts from the center is called principal axis and it is denoted or represented by capital P. When the rays of light are parallel to the principal axis strike the mirror, they are separated by the mirrors. As we know that the convex mirror always separates the light, but this separating happens in such a way that the backward projection, which are imaginary rays donated by the dotted lines, meet at a point on a principal axis behind the mirror. This point is called principal focus and it is represented by a capital F. The reflected rays appear to be coming from the principal focus, as you see in the figure, the dotted lines which meet in the principal axis and making the principal focus. Now, how to draw ray diagram for a convex mirror? Draw the object arrow in front of the mirror as shown in the picture. Trace two rays from head of the object arrow. One ray should be parallel to the principal axis and the other should meet the center C. Make regular reflections of these rays at the surface of the mirror. The angle of incidence and the angle of reflection should be equal. As we know that the first law of reflection that states the angle of reflection is always equal to the angle of incidence. So draw dotted backward projections of the reflected rays. You will see the image will form behind the mirrors where backward projection will meet. Now, what are the characteristics of image which is formed by the convex mirror? It is always virtual, always upright, always diminished, or always located behind the mirror. Now, what are the uses? Convex mirrors are uses in passenger mirrors in cars, hallway security mirrors, and blind corners. So, first use is passenger mirrors in cars. Convex mirrors are preferred in vehicles because they give an upright image as they are curved outward, so they provide a wider field of view. Second one is hallway security mirrors. These mirrors are often used in hallways of hotels, offices, malls, and shops for security purposes. Blind corners. They are also used on road, driveways, and alleys where there is lack of visibility, especially at curves and turns. These mirrors ensure road safety and prevent accidents. Now, secondly, we will discuss the concave mirrors. Now, what are concave mirrors? A concave mirror has its surface curved in such a way that its inner surface will reflect the light. For example, the bottom of an bottom of an inside silver bowl or the inner surface of the polished spoon act as a concave mirror as shown in the figure below. Now, how a concave mirrors behave with the incident light. As we discuss the behavior of light with convex mirrors, now we'll discuss how concave mirror will behave with the incident light. A concave mirror will always focuses the light, it will not spread the light. So a concave mirror focuses light after reflection. The mirror surface is curved with inner surface made reflecting. The reflecting surface is drawn smooth and the rough surface is made haired. When the rays of light that are parallel to the principal axis strike to the mirror, they are focused by the mirror, which is concave mirror. This focusing happens in such a way that the reflected rays meet at a point on the principal axis in front of the mirror. This point is called principal focus of a concave mirror, which is denoted by capital F. The principal focus of a concave mirror is always in front of the mirror. Now, how to draw a ray diagram for a concave mirror? There are two situations. Number one is when object is far away from the mirror. When object is far away from the mirror, draw the object arrows in front of the mirror but outside the principal focus. Trace two lines, first parallel and second towards the point C from head of the object arrow, and make regular reflections of these rays at the surface of the mirror. The angles of incidence and the angle of reflection should be equal. The image will form in front of the mirror where the reflected rays will meet. The image that is produced can be real or a virtual. Now, second case is when object is close to the mirror. Draw the object arrow in front of the mirror but inside the principal focus. Trace two rays, first parallel and second one is toward the center C from the head of the object, and make regular reflections as we made earlier of these rays at the surface of the mirror. The virtual image will form behind the mirror where the backward projections of the reflected rays will meet. So when object is far away, the image will form real or a virtual, but when object is close to the mirror, the image is always virtual. Now, what are the characteristics of an image that is formed by the concave mirrors? As we know that the concave mirrors forms two types of images, real and virtual. Now, firstly, we'll discuss the real image, that is inverted, diminished, located in front of the mirror and literally inverted. And virtual image is always upright, magnified, located behind the mirror and literally inverted. Now, what are the uses of concave mirrors? They are using in reflecting telescopes, shaving and makeup, lighting, laser, dental mirrors, and landing aircraft. So, number one is reflecting telescope. Concave mirrors are used in reflecting telescopes as studied earlier. Shaving and makeup mirrors in beauty salons and barber shop are slightly concave. They are used to provide the enlarged image of the face for applying makeup or shaving. Lighting. Concave mirrors collect light from a small light source such as bulb and direct it toward as a beam, as in flashlights, headlamps and spotlights. Another way is to collect light from a large area and focus it into the small spots as it focused solar power system. Third one is laser. Concave mirrors are used to form focused areas of light which are used in laser construction. Dental mirrors. Dentists use dental mirrors which have a concave surface to provide a magnified image. Landing aircraft. The mirror landing aid system of modern aircraft carriers also uses the concave mirrors. Thank you.